In this video, I'm going to demonstrate the use of two ADC channels. In the previous ADC videos, I've been using channel 0, which is ADC 0 here. If we would like to read another analog signal, we can use other channels along the ADC pins. Since my accelerometer has both an X and a Y axis, and we were reading the X axis before, I'm going to start reading the Y axis. I put another pin here, and on the breadboard, I'm connecting X to ADC 0 and Y, which is the next pin over, to ADC 1. To smooth the signal a little bit, we're going to be using the 10 microfarad capacitors as we did in the previous videos with the accelerometer on both of the channels. As previously, the accelerometer is connected to the 3.3 volt rail here. The ground is connected together all around the board, and we have the small power regulator for the 3.3 voltage output here, and the input is 5 volts on this side. If you have questions regarding the circuit that we've created here, please refer back to the initial accelerometer video where we put this circuit together. So let's see what the program would look like if we're using two of these channels. Let's start with our skeleton code like we usually do. We have the standard io.h, we have the Mr. LCD.h library file, so we can use the LCD and display our numbers from the analog to digital converter. We have our never-ending loop, which we are actually not going to be using we're not going to be putting any code inside here, but we'll just use this to keep the microcontroller going. And we have our interrupt service routine for the analog to digital converter. We can go ahead and add and include for the interrupt. And since we're using our interrupt and we have our interrupt service routine, we'll go ahead and include the global interrupts. Now we need to initialize the analog to digital converter. We'll start by setting the timing so the conversions will happen correctly, and we have to set the range between 50 and 200 kilohertz. And the way we do that is we use the analog to digital status register, and the bit that we're setting is the ADPS2. This is the bit that we set if our microcontroller is running at 1 megahertz. Now we need to inform the ADC that we're going to be using the internal voltage reference of 2.56 volts, and that's in the ADMUX register. And we're going to be setting ref S0 and ref S1. Now we need to enable the interrupt for the ADC, and that's under the ADIE, interrupt enable bit. And the final line in the initialization is we need to enable the ADC. After this global interrupt setting, we'll go ahead and establish a single conversion. Since we're going to be showing two values on the LCD, we need to provide an X and a Y label on the LCD. So we'll use our send a string with location command. And our X value is going to be 1, and our Y value is going to be 1. That's the top left of the screen for the first one. And we'll call this one X colon, and then we'll have the number happening just after that. The number will be at column, this is the first, this is the second, the third will have a space, and we'll have it on the fourth. Okay, we need one for the Y, so do the same thing with Y. We're going to put it one line down, so we'll have it on line 2. Since we're getting the 10-bit values, we don't need the ADLAR set. We're going to go ahead and make sure it's right justified, so it's easier to pick up the two values and put them together. Now, since we're using two channels, you might be wondering why I haven't set anything in here regarding the channels. And by default, the channel is going to be 0. If I was going to be wiring the X signal to 1 and then the Y signal to 2, I would need to put in a value here. And generally what I would do is it's under the ADMUX, and it's the last 4 binary digits for actually it's the last 5 binary digits of the ADMUX. It's from 0 to 4, the ADMUX register. And here I would just put in an OR and then the channel, which let's say we start with 1. We just put a 1 there. But since I'm starting with 0, I'm not going to put anything. I could put 0 here, but I really don't need to. And the reason why just putting an OR and a 0 or 1 there is because it's the last digits of the binary number, and just by putting a number in there, you'd be filling up the digits 0 through 4. I'm going to take this out. So let's go ahead and capture the ADC-L. And we're only going to be able to convert one channel at a time. So we're only going to be capturing the ADC-L and ADC-H once. But every time it goes through this interrupt service routine, we'll be doing one channel at a time. So we don't need two sets of these numbers to be captured. So let's go ahead and do the first one. This will be the 8-bit declared number. And we'll call it the low, as we did before. And this is going to be equal to the ADC-L. And then we had a 16-bit number called the 10-bit result. And this is going to be equal to the ADC-H, but it needs to make room for the ADC-L. So we have to move it to the left 8 spaces, since the ADC-L is populated with all 8 digits. And then we're going to OR the low, since this has been assigned the ADC-L. And this doesn't need to be shifted at all because it's just going to be on the end of the number. And we know at the end of this interrupt we want to start a new conversion, so it keeps going and going and going. I'll just take the one that's up here and I'll copy it, and it'll be at the end. Now this is the fun part. We need to determine the channel that it performed a conversion. Once we've done that, we need to make sure that the channel changes to the next channel. And then once this new conversion has been created, that new channel will be set, and we'll capture that information, that result, and then we'll set it back to the other channel, and then it'll start it over again. So every time it goes through this interrupt service routine, it's flipping the channel. It's going to channel 0 once, and then it gets the number and it'll print it out on the display, and then it'll go around again with the channel 1 and display that, go around again, channel 0, display that, go around again, channel 1, display that. And there are two different ways we can do this, or two relatively easy ways we can do the switching of channels and displaying the number on the LCD. And one way is using if and else statements, and the other way is using the switch statement. I'm going to be using the latter, but I'll also show you what it means in the if-else statements as well. The switch statement is similar to a menu. When you make a selection on a menu, you're really only making one selection, like a menu at a restaurant. When you want to order an entree, you're going to pick only one of those entrees, unless you like to pick two of those entrees. But in this case, you're only really allowed to pick one entree. The switch statement is going to determine what channel we're in, and it's going to select that particular channel. It's going to print out the data from that channel, and then it's going to set the next channel. So the switch statement goes like this. It's a switch command, and then you have parentheses. You're containing a variable that you're going to be determining what value it has. And then we have the code block with our brackets, as usual. And we have case. This is like in case. In case the value is equal to whatever this is, it will run some code. So let's say, I'll just call that value. And then we use a colon. And then we use a number of statements. We'll have code line 1, code line 2, code line 3, and so on. And then we have to end with break. And every one of these cases will be ending in a break. And we'll have multiple cases. And these are like the menu selections. And we can have as many of these cases as we want. And then we have a default case, which if it doesn't equal any of these cases, if it doesn't equal any of these values, the variable, let me just put a variable here. If this variable is not matched by any of these cases, any of these menu selections, then we have to, well, it'll go to a default. And you can have special code in this default. And it can be as many lines as you need, and then this also has the break. And this generally says that, let's say this is a variable of how old I am. This is Patrick's age. And then it'll have 1 through 100. And once it gets to the 42 case, it will run the lines of code, and then it will break out of this entire switch statement. So it'll only be allowed to be equal to one case. Because we're going to be setting the channel in AddMux, that's going to be our variable. We're going to determine the value of the channel that is going to be set. So let's just say in case this value is going to be 1, or is actually 0, this would be the 0 case, and this would be the 1 case. This would be the channel 1 or ADC 0. This code will run if the ADC is 1, the channel 1, this will be the Y and this will be the X. Now let me show you the equivalent in an if-else statement. And this would be equivalent to if AddMux is equal to 0, then it will do some code. And then we'll have else if AddMux is equal to 1, then we'd have another set of code, just like we have here. And this is actually a little bit lengthier than the if-else if, but it's a lot more readable. And also, when we're doing not just 2 channels, we can have as many channels as we want, as much as the AVR will give us. And this would be up to 8 channels, 0 through 7. We can just increase the number of cases in here, and it's very readable, and you can just add the cases as if they're menu items. So let me take this portion out, and let's put the code in here. First, I need to inform you about the way we're going to be reading AddMux. We're not going to be reading just 0 here, because there's other bits that we've set in AddMux. In AddMux, we've set the ref 0 bit, and we've set the ref s1 bit. And the ref s0 and the ref s1 bits are in the bit number 6 and bit number 7. So it would be set like this: 0b, which is binary, 1 1, which are these two first numbers, the ref s0 and ref s1, and then we have 2 zeros here and then 4 more zeros here. And these zeros here, the five zeros from 0 through 4, are the channel bits. So we will have either the bits set like this, or we'll have the bits set like this. This would be channel 0, because the 5 bits here would be all 0, and then these 5 bits has a 1 here, so that just equals channel 1. If it was set like this would be channel 2. But we know that this entire number is not 0, and this entire number is not 1. We have to figure out how to convert this into a hex number, and this is pretty simple actually. Let's separate these two out so we can look at these in 4-bit increments. Now we know that this is the 1 bit, this is the 2 bit, this is the 4 bit, and this is the 8 bit. So if we add 8 plus 4, we get 12. And in hexadecimal, 12 equals C. And to prove that, 8 equals 8, 9 equals 9, 10 equals A, 11 equals B, and 12 equals C. So this portion of the 8-bit number is C. And this portion of the 8-bit number is 0, and this portion of the 8-bit number is 1. So we can determine the cases if it's either C0 or if it's C1. If ADLAR was set, then we would have to have a different number. Let's go ahead and just go through that. If ADLAR is set, we'd have 1110. And this is 2, this is 4, and this is 8. So 8 plus 4 is 12, plus 2 is 14. So what letter would that be? So we have 8 is 8, 9 is 9, 10 is A, 11 is B, 12 is C, 13 is D, and 14 is E. So if we had the ADLAR set, then we would be testing E0 or E1. So we can put in here C0, and C1. So this is saying if addmux is equal to C0, which is in looking at channel 0 and the ref S1 and S0 is set, it will do these lines of code. If addmux is equal to C1, it will do these lines of code. Now we know we want to set a different channel once we have captured the information for channel 0. Let's say it was doing channel 0. It captured the information, and in this code I want to be able to print out the LCD, print out the contents to the LCD on the appropriate line, and then I want it to set to C1, so the next time it goes around it will be C1, and then it will go into this code, and in this code I'll set it back to C0. So every time it comes through here, it will be setting the alternate channel. So let's put that easy part of the code in. The addmux is now going to be equal to C1 in this case, and here it could be addmux is going to be equal to C0. Now let's display the number to the LCD. We're going to do that in this set of code, and we're going to do that in this set of code. So since we're working with the x-axis here, let me just get rid of all this code, and I'm going to type in send an integer to Mr. LCD. And the x value is 4 that we calculated before, because there's 3 spaces and then we wanted to start on the 4th space. And this is on the first line, and this is going to be equal to the 10-bit result. Oh yeah, and the result will have a maximum of 4 digits. So let's add that to the y. And this will be on the second line, and that's it. But it would help, actually, this is not really a hex number unless you put the 0x in front of it. So let's do that, 0x. And a good way to tell if you have an error, it doesn't have a special color for what you're putting in. So if it's just black, then you kind of know that it may be erroring or not correct. So let's review the code that we've put in. We are using the io.h, which is a standard file. We're enabling the interrupts, including the interrupt header file. We're also including the Mr. LCD.h file, which is our library for the LCD. We're initializing the LCD. We're adding a couple labels to the LCD, an X label and a Y label. We have the timing set correctly for the ADC. We are enabling the internal voltage reference. Let me get rid of this space. We have the interrupts enabled for the ADC. We have the ADC enabled here, and then we're starting our first single conversion. This is setting the global interrupts. We have this while 1, so we continually have the microcontroller on, and this is just an infinite loop. And then we have the actual interrupt service routine, and it's capturing the result of the ADC, which is the 10-bit result. It's storing it in the 16-bit variable. We're getting the low register captured conversion, and we're storing it into a variable because we need to access the low first before we access the high, and then we shift the high register 8 spaces over so we can make way for the low. Then we use a menu switch statement to determine first which channel that we are getting the result, and we're gonna, if it is channel C0, if it is channel 0, then we're gonna display the result from channel 0 on line 1, and then we set it to channel 1. If it is channel 1 that we have selected, then we're gonna print it to the second line, and we'll set it to channel 0. And C doesn't mean channel, it just means the hex number corresponding to the ref S0 and ref S1. And then we go ahead and do another single conversion so it's able to come back to the interrupt service routine and do this all over again. So let's see if this code actually works. I'm going to make and program the microcontroller, and let's see what we get. Okay, the microcontroller has been programmed, and it looks like on the LCD we have two different numbers, an X and a Y. Those labels were displayed correctly, and we have two numbers. Let me pull back here a little bit. If I tilt the accelerometer this way, you can see that its x-axis is reducing, and if I turn it this way, the x-axis is increasing. And if I turn it in this direction, the y-axis is moving, is decreasing, and if I tilt it in this direction, the y-axis is increasing. So we have successfully connected our channel 0 and channel 1. We've programmed it so they are showing independently on the LCD. And if we wanted to increase the channels, all we'd have to do is wire the devices to the other channels and increase the number of case statements that we have in the switch. So that is how you use multiple channels in ADC. Thank you for watching. If you are following along with these experiments or producing successful projects on your own, helped by these tutorials, please let me know using the Contact Us page on the newbiehack.com website. I would like to feature these on the website to benefit and motivate others to join this creative field. Thank you.